Okay, we are on, we are rolling. This is, what's the date today? September 17th? 17th. Today is December, no, not December, September. No, I'm too old to want my life to spin past me that quickly. It's September 17th. Thank you. Excellent. Okay. Now, if you look at page 1 of your chapter, you'll see that chapter 1 is entitled Motion, correct? That's page 4 of the student textbook, okay? Yeah. Now, if you just turn the page, it says, section 1 is you're describing and measuring motion, right? Now, we described motion. One of the first videos we made was relative to describing motion, wasn't it? Reference points, yes? Relative motion. Remember the guy on E10 that just was going the same speed as we were? What was their speed relative to me or relative to you in your car? What was their speed? If they're going the same speed you're going, and you're going 120 kilometers per hour, and they're going 120 kilometers per hour, what's their speed relative to the road? 120 kilometers per hour. Very good. What's their speed relative to yours? 0. Very good. I am impressed. Then we started to talk about distance, measuring distance, didn't we? And we actually did a lab on measuring distance. And near the end of this class, I want to send students out 2 at a time to see if they can refine their strides. And I want them to see if they can figure it out themselves. And then I want to see if we can measure, if each student can measure the distance of the hallway outside within just a few percentages in error. Okay? Clear? Let's see if we can actually do that. The stride that we're going to be doing motion for 2 months probably in here. So your ability to measure stride is going to be critical in evaluating motion, don't you think? Does that make sense? Okay. Now, we've got to push on. I would say we're far behind, but we're certainly getting there. Okay? I will give you and your parents, hopefully they're watching this too, maybe they can have a talk with you, you can have a heart-to-heart with your parents. This is what I've noticed. It's not a bad thing, it's just a thing. That when you do lab work, and we do experiments, it's very important for you to keep your eye on what you're doing and how you're doing it with your lab partner. It doesn't matter how another group is doing it. What's important is for you to pay attention and to understand what you're doing with your lab partner. And when you work with your lab partner, you don't argue about the lab. You can certainly discuss it. But if indeed you come to an impasse, you don't raise your voice and argue. This isn't debate where there's a little bit of a clash maybe. You ask me for clarification, and I'll give you clarification. And my judgment is final and absolute. Is that clear? If you don't agree with me, during class is not the time to have a debate. You can certainly come to me after class or after school and we can discuss it, and you may have a valid point. But if I have 20 students doing a lab, I need people doing the lab as I've instructed them to do it. Is that clear? What happens if that isn't being done? Well, you can have safety problems, right? And do you think I'm going to trust students with labs that require you to observe safety guidelines if you're arguing with each other and not doing what I asked you to do and how I asked you to do it. When you do lab work, slow and steady is the way to do it. There's no rush. The worst thing to happen is you don't finish and you come after school and finish it. Last year, one of the most interesting or curious ideas was that students, when I asked them to come after school for extra help, they would break into tears and they would cry because they didn't want to come after school. They thought that was a horrid thing. They would. Some of them brought their parents because they were so afraid to come after school. And that's okay. Bring your parents, it's not a problem. They can sit down and do the lab with you for all I care. It doesn't bother me. But don't think that coming after school for extra help is the result of some type of criminal behavior on your part that you're being punished for. What? Come after school for extra help anytime you want, and bring a friend. Bring a friend who knows what they're doing, and you can work together and then ask me for help if you need it. But oftentimes in class, you may not understand what I'm saying. What is Mr. Darcy talking about? I don't understand anything the guy is saying. You know, George, do you understand what the man is saying? I have no idea. Can we come after school and work together? Because you seem to know what's going on and I don't. And then if we suffer enough and we both don't get it, or I confuse you, then we can ask Mr. Darcy and then we may actually understand what he's saying. Isn't that a good idea, George? George, do you think so? Absolutely. Absolutely, Bea. I think that's a great idea. Let's do it. Good idea?
Yes.
I'm not going to go after school because it's the result of some kind of criminal behavior on my part, and it's some type of sentence that has to be carried out as reparations for whatever it is I did. No, you're coming after school because it's sometimes part of the process. Clear? And it reduces some of the frustrations at home. Is that enough said? Can I move on? Okay. We looked at motion so far. And we looked at really distance, didn't we? We looked at distance. Right? And we measured distance. And how many people found out that measuring distance is a little bit more complicated than you thought it was before last week? Raise your hand. How many people didn't hear the question? All right, let's ask the question again. And if you raise your hand, it's okay. All right? How many people felt after last week when we did the lab that distance, measuring distance, is a bit more complicated than you thought it was? Raise your hand. Nearly the entire class is raising their hand. It's absolutely unbelievable. And you know what? That was one of the ideas I wanted to get across to you. Introductory science students in physics think that physics is very easy because, hey, distance, I know what distance is, but it's not as easy as you think relative to measuring. And we're going to work on that. Because if you can measure distance, that's going to be a major part of the battle. Clear? All right. Now what I want to do is I want to talk about time. When you talk about time, what's the first thing to pop into your mind about time? Yes? A clock. Excellent. We like that. A clock. What else? Yes, Bea.
Seconds, minutes, and hours.
Seconds, minutes, hours. Excellent. What else? Yes. Numbers. I like that. Numbers. Numbers. Clock, seconds, minutes, hours, numbers. What else? Excuse me, this is what I hear. You gotta speak up. Don't be shy. Okay? Pretend you're in Yankee Stadium and you've got to yell across the stadium. Do you ever yell loudly with your friends when you're outside? I think you do. Yell like you're a crazy person. What did you say? That's even more quiet. Could I have an interpretation? What did he say? Yes.
Days, weeks, and years.
Days, weeks, and years. That's good. Days, weeks, years. Good. What else? Anybody? Yes. Centuries. I like that. Centuries. Century. What was a group? What was a group of 100 Roman soldiers led by? What was a group of 100 Roman soldiers led by? What was the name of the person who led 100 Roman troops? Was it sergeant? Was it major? What was it? Yes. Close. Yes. Sergeant? that probably would be my guess. But what does century mean? What does century mean? Yeah. Does anybody know what a century is? Craig? 100 years, yeah. Centurion. A centurion was a rank, and it was the person who led 100 soldiers in battle. They were called centurions. They were pretty important people in the Roman army. Pretty important. Yeah. What else? What else do you think of? Yes? Changes. Oh, I like that. Nobody said that. Changes. That's probably one of the more important things we're going to realize about time. It's hard to keep from changing. Wouldn't it be wonderful if we could stop time? That would be great. Yes? Eternity. I like that. Like infinite, eternity. What else? Anybody? Yes? What is it? Speed. It's interesting you said speed. I like that. Speed. Okay. Now, so we all have different ideas of time. We all measure time in different ways. We understand the different measurements of time, even at your age. We know what a week is. We know what a day is. Some days are long and some days are short. Right? Yeah. We know what a month is. How many months in a year? 12. I mean, you know that, right? Okay. Well, what's the SI? Do you remember SI? What SI is? Do you remember? Remember we pronounced that? Yes. What's SI? Say that again? International System of Units. Systems International. I could never even begin to say it as well as you do in French. Okay? However, what is the correct way to represent time in International System of Units? Systems International. How do they represent time? Do they do it by centuries? Do they do it by weeks? Days? Months? Years? Years? Yeah? No? How about hours? It's hours, right? It's hours? How many people think hours? Raise your hand. Right? Yeah. Nope. It's going to be seconds. Seconds are what is used. Those are the standard units for time in Systems International. And what's the symbol for it? T for time? How many people think T for time, raise your hand, is a symbol for seconds? Nope, it's not. What else? What is, do you think? Context clues. What do you think? Small s. That's right, small s. Now, what we're going to talk about today is we're going to look at a ratio. How many people know what ratio is? What's a ratio? What two things does a ratio have? You're thinking a ratio like this, right? You could say it has a numerator and a denominator. You could say it has two parts. What is a ratio? Yes?
There's one number on the
One on the top and one on the bottom, okay. But what is a ratio? What is a ratio? Can you define it in your own words? Yes? Okay, I need to, what do you say? I didn't hear. A letter that replaces a number. Okay, I like that. Like in math, like a variable. Yes? What did he say?
You have to like shout.
Yeah, you don't want to shout? There's a large fan on in here that's really distracting. And I'm a little deaf. I know. Look at this. I know. It's like black holes in space. I mean, you get this noise out of these fans. And if you don't, all right, try it again and I'll try to hear. Go ahead. Say it loudly. I know you can shout.
Yeah. There's number 4 and number 2.
Number 4 and number 2. Okay. I like it. I like it. Yeah. I like your accent. It's an excellent accent.
So you do the 2 to 1.
2 to 1. So what are you doing? What are you doing? So it's 4 to 2 or 2 to 1. But what are you doing with the numbers? You're doing what? It starts with a C. Well, who said that? Yeah, that's exactly. You're comparing them, aren't you? And what is the number 2? What does it represent? It represents what? 2 boys to 1 girl, maybe, or 2 girls to 1 boy. It could be. You could be comparing. Concepts, ideas, right? Yes? What we're going to do is we're going to write a ratio that's going to compare 2 ideas. Okay? Anybody know what those 2 ideas is going to be? Yes? What is it? Motion and time. Did a dog just bark? What happened? Oh, it was a chair. It sounded like a dog barking. What was that? Is that a dog barking? Well, who did that? Did you do it, Jorge? All right. It sounded like a dog barking. Maybe I'm losing my mind. Maybe there are ghosts in this room. You never know. Okay. So it's going to be distance over time. Okay, distance over time. I'm going to compare distance with time. And what are we going to call that? Distance versus time. What are we going to call it? We're going to call it speed. We're going to call it speed. Okay. So the ratio of distance over time is called, and that's going to be equal to speed. Okay? The ratio of distance to time is going to be called speed. Right. Tell me some speeds you're aware of. Like, yes? Fast car. Like, what's fast to you in a car? What's fast that you've experienced? I don't want you to go out and try to experience really fast speeds, but just speeds that you're familiar with. Yes? I can't hear you. 300 knots? So you're kind of like a sailing guy? I'm not sure I want, oh, on a plane, okay, well that's better. I'm not sure I want to be in a boat that's going 300 knots. Okay, that's a little scary. A plane, 300 knots. What's knots? What does that mean? He says 300 knots. We're talking about distance and time, and he's talking about knots. What's knots? Yes. Yeah, it's kind of a speed. It's kind of like a nautical speed. We'll talk about knots, but not right now. But knots is like, I didn't say snots. I said knots, thank you. Kids, you know. Can we not talk about knots right now? How many people have never heard of knots? Raise your hand. Yeah, I'd say the entire class have never heard of knots. But that's okay. You'll hear knots as you get older. In the history of knots, so let's not talk about knots. But yeah, 300 knots is around miles an hour, right? Isn't that what a knot is? It's a little bit different from that, but not terribly different. Can someone look up the word knots for me, please? You two back there, Craig and Mr. Knots. Can you look up that, please? Okay. Now, so I think there's something we have to get down here. What is distance measured in? Remember we talked about this. What's the SI unit for distance? Meter, very good. So distance is meter and time is seconds. So this is going to be meters per second. So that's going to be the speed, not knots. But anyway, knots are important, not a problem. I admire anybody who understands knots, but I asked the question, didn't I? How many people are familiar with certain speed, didn't I? And he said 300 knots. He answered my question, didn't he? Right? Yes. Give me your best shot. What do you think? What are knots? You're going to have to speak up, right? I'm getting to hear you a little bit better. You're kind of loosening up a little bit. Don't be afraid to shout. You're not going to scare me. All right, so say that again. A knot is a unit of speed. Oh, a knot. Yeah, go ahead. 1 knot or mile? 1 nautical mile. Okay, so a knot is a nautical mile. .852 kilometers per hour. Okay, so it's about, 1 knot equals 1.8 kilometers per hour, correct? Is that right? 1 knot? 1.852. Right? Well, it's interesting to know that 1 mile per hour equals 1.6 kilometers per hour. So a knot is, didn't I say that was a little faster than a mile per hour? Yeah, so it's a little faster. Yes. Okay. So say that again. 1 knot. 1.151 miles per hour. So it's pretty close, yeah? Pretty close? So, and there's a whole history behind where they get knots. You know, why do they have knots? Well, we're not going to talk about that now because I really like to do some other work, okay? But all I wanted to do in this first film is kind of define, because are people kind of getting a little bit tired of the discussion so far? You're starting to get, I can see you getting burned out, so I'm going to stop in a minute, okay? But, so this is what we have, okay? This is what we have, okay? We have distance over time. You okay with that? Okay, now. I'm almost finished. All right, almost finished. I know. Okay. The knots really kind of, how many people got thrown by the knots? It's a good thing. We like that. Not a problem, but okay. So we want to talk about two things. You ready? Average speed, and we want to talk about instantaneous. Speed. Okay? What is average speed and instantaneous speed? Anybody know? It's actually very simple. If you drive to Dubai, and we know we're just going to make up a number. Okay? Is that okay? Yeah? Is that okay? Let's say that to Dubai is 80 kilometers away by road. 80 kilometers. Is that okay? Okay. And we're going to say it takes an hour to get there. Okay? Yes? What's the average speed? Did I go 80 kilometers per hour all the way there? No, I stop, go, slow down, speed up, right? Traffic, crawl. So how did I get the average speed? How do I do that? Well, that equals simply the distance over the time. So plug in 80 kilometers, 1 hour. Divide through, what do you get? What's the average speed? What is it? It's going to be 80 kilometers per hour. Yes? What's the instantaneous speed? Yes?
Your speed right now.
Yes! Right now. Right now. 1, 2, 3, 4, 5. Okay. How do you get the instantaneous speed? Yeah. Speedometer. Yeah. So you want to look at the speedometer. Is that coming up on the film? Let's make sure. Pretty good. Not bad. Not bad. Okay. So you look at the speedometer. Okay, you look at the speedometer, right? One eyebrow. Nyeh. Okay. All right. My grandfather had one eyebrow. Like, he looked like Greek longshoreman. He has, one eyebrow going from here, down his face, across above his eyes like this. It looked like this. It looked like, does that look good?
Superman.
Superman, okay. Super Turkman, okay. Okay, so, got your attention, huh? So, you have two things. Is it gone?
Yeah. No, there's a lot. There's a lot.
So, what happens is, you have average speed, and you have 80 kilometers per hour. You have the instantaneous speed, which is simply, you look at the speedometer. What am I going at that point? You run a race. You start at 0. Are you going to end at 0? No. You're going to accelerate, right? You're going to pick up speed, right? And you're going to end at a certain speed, aren't you? Right? Well, what speed did you end at? Well, that would be the instantaneous speed, right? When you end a race, when you cross that finish line, it took you an hour to do it, to ride that race on a bike. Anybody biking here? Okay. Your dad bikes to school every day. Okay, so the speed he ends with when he gets home, is that the speed he starts with? Is that the speed he goes every point of the way? No. It's the speed you end with is could be your instantaneous speed, unless you're stopping. But when you cross that finish line, the speed you cross the finish line at, is that the speed you had throughout the entire race? No, that is not the instantaneous speed. Aren't there many instantaneous speeds? That's the finish line instantaneous speed. When they take the picture of the horses crossing the finish line, the photo finish, and you see their, heads up, got him by a nose. That's the instantaneous speed at that moment in time when the picture was taken. Pretty good click. Isn't that good click? You ready? You hear it again? You ready? You ready? Cool, huh? All right, once more. Once more. Okay? So that's the instantaneous speed in that particular moment in time that you can capture on a camera. And we're done.
I don't know, it's gonna be more than, it won't shut off.